Welcome to the first episode on business mathematics. I am Henry Eniu Entry, your tutor for today. In today's lecture, we are going to be looking at monomials and polynomials. Let's look at what monomial is. So, monomial is an algebraic expression with only one term. So, an example of monomial is, so let's write the definition. Monomial is an algebraic expression. It's an algebraic expression with only one term. So example of this algebraic expression or monomial. So an example of monomial example is 7x. This one, we also have 7x squared. We also have 7xy. So this is an example of monomial. Now, how would you know that this is an example of monomials? So let's look at that. So how do we identify an expression as monomial? Now let's look at this. In our definition, we said monomial is an algebraic expression with one term. So one, to identify a monomial, it must have one term. So that is the 7x we have over here. It has only one term over here. Then also it must have, or it should have, a whole number exponent. So we have 7x squared. It's also a whole number exponent, right? So it has a whole number exponent. That is the 2. And also it should have no variable in the denominator. So there should be no variable in the denominator. So now let's look at this expression. We have ax raised to the power n. Now let's explain this in monomial, right? So over here, the a becomes our coefficient. So the a becomes our coefficient. So coefficient, right? So coefficient. Now, that is the number in front of. So that's the number in front. So it becomes the coefficient of x. Now the x becomes the variable. The x becomes the variable. And the n becomes the exponent or the whole number exponent. So the n becomes the whole number exponent. So a becomes the coefficient of x is the variable, and n becomes the whole number exponent. It can be any number. Now let's look at this. We have 5x raised to the power 2. 5x raised to the power 2. Over here, the 5 becomes what? The coefficient. So the 5 becomes the coefficient. The coefficient, the x becomes the variable. Always put this in your head, and the 2 becomes the whole number exponent. Whole number exponent. I hope you understand this. I have these numbers over here. So how do we identify these numbers as monomials or not? So now let's try. The first example we have over here is 7x. Note that monomials have only one term. So therefore this is a monomial. Now, monomial. The reason is it has what? It has only one term. Please, do you get it? Now, let's look at the second number. That is 7x squared. Is it a monomial or not? So this is a monomial. Why is this a monomial? It's because it has a whole number exponent. So it has a whole number exponent. So 1. Now, what of this? What of this? 5mn. Is it a monomial or not? This is a monomial. Why is this a monomial? Because it has a variable. It has a variable. It has a product of variable, or it has a variable. Now note that in our previous example, we gave an example like this. We gave an example like this. Now, like this. And we said 5 is what? The coefficient, right? Now, x is what? The variable. So over here, no, I think we use this. Yes, the ax raised to the power this. So like this, we said the a is a coefficient and x is a variable. So this has a variable. So the 5 becomes our coefficient and this mn becomes our variables. Right. So now let's move on. Now what about this? What about this? 9 over y. Is this a monomial? Is this a monomial? No, this is not a monomial. So we say no. Why is this not a monomial? Now, it has variable in the denominator. There is variable in the denominator. This is a variable, right? This is a variable. So note that if there is a variable in the denominator, it is not a monomial. So in case this was to be a number, maybe this would be a monomial. But since this is a variable, it's not a monomial. So it has a variable. So it's not a monomial. Now let's look at the last one. We have x exponent -3. Is this a monomial? No. Why is this not a monomial? Note that we said monomial has a whole number exponent. So this is not a whole number. It carries a negative sign in front of the whole number. So therefore, this is not a monomial. Please, do we understand this? Now, we've identified whether this is a monomial or not. So 1, to identify things, please keep these things in your head, sorry. So a monomial has only one term. 2, a monomial has a whole number exponent, and also a monomial has a variable, or a product of variable. Monomial has a product of variables. Now, to identify whether this is not a monomial, 1, you are going to see a denominator with a variable. It means that it is not a monomial. Also, with a negative exponent, it means this is not a monomial. Now, let's look at business examples of monomials. So example 1, over here we have unit cost model. So the question is, if cost per item is 10 Ghana cedis and X items are products. So the question here, let me break this question down. So it is saying, if a company sells item at 10 Ghana cedis each and sell X items, what is the total cost? Or the total cost is, so right now we have to express this. Now, they said what? 10. So if cost per item is what? 10 Ghana cedis. So let's see be the cost. So the cost per item is what? 10 Ghana cedis. And X items are products, right? So we add X to this. So this will be the answer. Now, is this a monomial or not? So is this a monomial or not? Yes, This is a monomial. Why? Because it has only one term, that is 10x. So it has only one term. So the question was, if cost per item is 10 Ghana cedis and X item are product. So you have to express this. You have to provide your answer, the final answer as this. This is in sentence. So you have to express this mathematically. So this is what? The C to be what? The cost is equal to. So if cost per item is this 10 Ghana cedis and X item are product. So this is the final answer. Please, are we good? Now let's look at another example. So now let's look at example 2 over here. So if commission is 3 Ghana cedi per sale and someone makes X sale. Now the commission earnings. So over here we have the earnings. So this is going to be your answer. So the earning will be what? E. So the E is going to be your commission earnings, right? Your commission earnings. So E to be your commission earnings. If commission is 3 Ghana cedis, so 3 per sale, and someone makes X sale, so like this. So this will be your answer. Is this a monomial? Yes, it is. Why? Because it has only one term. So example 2 was on what? Commission and earnings. That was the topic. So if commission is 3 Ghana cedi per sale, so the E stands out. Remember the first one was a unit cost model. Yes, unit cost model. So the C was the unit cost model, right? So over here we have commission earning. If commission is 3 Ghana cedi per sale and someone makes X sales, so E is our commission earnings is equal to 3 Ghana per sale over here, and someone makes X sale. So this is the meaning of this, right? In mathematical form. So mathematically, this is the statement, right? So this is a monomial because it has only one term. Please, I hope you understand. It has only one term. Now let's move to the next idea. If commission is 5 Ghana cedi per sale and someone makes X sale. So I leave this to you. Solve this and drop it in the comment section. Let me look at it, whether indeed you've really learned something. So I'm not going to solve this though. So please, if you are watching this video, kindly solve the question. Just drop your answer in the comment section. Now let's move to polynomials, right? Now let's look at polynomials. So what is polynomials? Polynomials is an expression that is made up of two or more monomials added or subtracted. So let's write the definition here. So polynomials is an expression that is made up of two or more monomials added or subtracted. So this is the definition of monomial. It's an expression that is made up of two or more monomials added or subtracted. Now let's move on. So the general form. Now let's look at the general form for polynomials. So the general form for polynomials. So per the definition we have here, this is the general form for polynomials. So over here we have a. So we have an down here, x n plus a n minus 1. Don't worry, I'll explain it. Then we have x n minus 1 plus, now continuing like that, then we have a1x plus a2. So the general form for polynomial, right? So as we move on, you understand. So per the definition, now let's put this aside for the moment. I'll explain this, or you understand whilst we move on. So the definition says two or more monomial added or subtracted. So this is an example of, polynomial. So polynomials, an example of polynomial is, so it is made up of two or more monomials. So we have 5x plus 1. So this is a monomial plus 1. So this is a polynomial. It has two terms, so it is called a binomial. Now let's look at the types of polynomials. So let's look at the types of what polynomials. Now let's look at the types of polynomials. Now by number of terms, one term is what? Monomials. Two term is binomial. Three term is what? Trinomial. So let me remove the x. Let me omit this x. So now we already know an example of this monomial, that is, let's say 7x. It has only one term. An example of binomial is what? 5x plus 1. It has two terms over there. Now let's look at trinomials. So an example of trinomial is, let's say 2x squared. So it has monomial, two terms plus. So let's say, or let's use this. So this 1x plus what? 5. So the trinomial is even as a quadratic equation. It looks like a quadratic, not that it looks like, it is a quadratic, because quadratic, we have a squared, then we have bx plus what? C. This is a quadratic equation, and looking at this, this is also a quadratic equation. So the trinomial term, or the three term, that's the trinomial. This is an example of it. Now let's look at the degree. Right, we looked at the types of polynomials by numbers of terms, right? Number of terms. We had the one term to be monomial, two term to be binomial, three term to be trinomial. Now let's look at degree. So by degree, or polynomial by degree. So degree is the highest number or the highest power of x. So also we also have a degree from 1 to 3. So let's draw our table over here. Over here will be degree. So we have degree 1, degree 2, and degree 3. Now we have our name over here. So this is our table. Then over here we have an example. Now degree 1 is also known as what? Linear. Is also known as linear. Now, an example of this linear is 3x plus 2. Now, this 3x plus 2 falls under binomial. Why does it fall under binomial? Because it has what? Two terms. Now, we move to degree 2. The degree 2 becomes quadratic. So quadratic. So an example of quadratic is 3x squared plus what? 6x plus what? 2. So this falls under what? Trinomials. So trinomial. right? Now, let's look at the third one. So the third one is what? Cube, cubic. So the third one over here is what? Cubic. Now, example is, let's use this. Now, let me explain. The degree tells us how the graph will behave. How the graph will behave. So this is how the degree tells us. So the degree tells us how the graph will behave. Now looking at the linear. Now let's look at linear. Linear is a straight line. This is a straight line, right? You understand how to move on. So the linear becomes a straight line. The quadratic becomes the curve. When you are solving for a graph, this becomes your straight line, this becomes your curve. Now the cubic becomes more complex curve. This is the cubic. It becomes what? More complex curve. Now, we are still looking at the types of polynomials. Don't worry, you understand everything once I give you questions on it. So we move to the third one where we have business application. So types of polynomials by business application. So I'll explain this slowly too for you to understand. Now let's move to business application of polynomials. So you are going to understand in this section, you are going to understand everything we said about the types of polynomials, right? So this is where students should pay much attention to. So business application of polynomials. Now, this is the formula for calculating a profit model, right? So under business application of polynomials, we have profit model. So profit model. Now, the formula for calculating or profit model is equal to revenue minus cost. So profit model is equal to revenue. Please keep this formula in your head. Revenue minus cost. Now let me write it mathematically. So profit model. So profit model or profit. So you can write profit. So it is denoted, or the symbol or the sign is II, like this, is equal to revenue. So revenue, write your revenue minus cost. So the revenue becomes what? R, and the cost becomes what? C. So the formula for profit model is revenue minus cost. So now let's solve an example. Now over here they said giving revenue uh, giving revenue is equal to 20x, cost is equal to 5x plus 20. So this is it. Now we are to solve for profit model. So how do we solve for this? So remember the formula. We said profit, that is II, like this, is equal to revenue. Now the revenue we have over here is 20x. Now minus what? So the revenue we have here is 20x. So you are going to substitute into the formula. So 20x minus now 5x plus what? 20. So this is it. Now, how do we solve for this? So this is the cost, right? And this is the revenue. So like this. Now, let's simplify, right? Let's simplify this. So let me clean the board for us to solve this well. So now, over here we have the revenue to be 20x, the cost to be 5x plus 20. Now we have to solve for the profit model, right? So profit is equal to revenue minus cost. So the profit, that is II, is equal to the revenue, which is 20x minus the cost, 5x plus 20. So this is it. This is revenue, this is cost. Now, this one is cost. We have to solve for cost. Note that whenever you see an expression like this, minus, maybe let's say as we have 20x, let's use the example we have 20x minus 5x plus 20, right? So this is in a bracket. This is cost and this is revenue. So how do we solve for the one in a bracket? Because there is a negative sign, always there is a 1 over here, but we don't write the 1. In mass, we don't write the 1, but there is 1 over here, invisible. So this 1 times 5 is going to give you what? Negative 5x. Now this 1 times 20 is going to give you negative 20. So in, we say negative times positive is going to give you negative. Please, do you understand? So we solve for this. There is a 1 here that is invisible. So this 1 times this, you are going to get, okay, let's write our 20x. So let's continue to solve. 20x minus. So you multiply this, you are going to get this. And you multiply this, you are going to get this. Now, after getting this, we group like terms. So let's group our like terms over here. So we have this. Now we subtract. So we have 15x minus 20. Looking at this, these are not like terms. So therefore, this will be our final answer, or this will be the profit model for this. Please, do you get it? So over here, the 15x becomes the profit per unit, and also the 20 becomes our fixed cost. So over here, the 15x becomes profit per unit, then the 20 becomes what? The fixed cost. Please, I hope you get it. So this is our final answer. So if profit is equal to 0, that is break even. So whenever the profit is equal to 0, let's say 0, after we had this 0x, then it means it is break even. That is called break even. So whenever profit is 0, it is break even. Now let's look at a break even example. So an example where we get a break even, right? So now let's look at example, or a break-even example. So the question says we have 5, as I usually do. Let me divide my board. So I have 5, 50x minus 2000 equals 0. So whenever you see a scenario or an example like this, we are looking at, or we are dealing with break-even examples. So we have to solve this, right? So we have to solve this. Now, to solve this, first, let's ignore this 0. So let's write 5 or 50. This 50, then 50x. Okay. All right. Now, we don't have to ignore the 0. Sorry. You don't have to ignore the 0. So this is an expression, right? So you group like terms. So this and this are like terms. So 50x is equal to, now when this negative crosses the equal to sign, it becomes positive. So we don't write plus 2000, we just write what? 2000 over here. Now we divide both sides by what? 50 and also 50. So 50x. So 50 we divide 50. Now let's bring our calculators over here. We are solving mass. So over here, this is my calculator. So 2000 over 50. So you are going to get what? your final answer to be x is equal to 40. So your final answer is what? X is equal to 40. Now let me explain the answer. Now, the business must sell 40 items to cover costs. So this means that the business must sell 40 items. So the X, we were looking for X, the items. Sorry, I didn't give any question. We just solved this. But let's say, for instance, we have to find for X, the items. So in order to find for X, we had what? 40. So the business must sell 40 items to cover what? Cost. Don't worry, I'll give you real examples. I just want you to understand this, the concept, right? Now, let's move to the quadratic revenue model. So let's move to quadratic revenue model. Now, let's look at revenue model. So this is a formula for revenue model. We have revenue is equal to price, that is P, times quantity X. So let's write this in simple terms. So R revenue is equal to P times what? X. So the X is our quantity. Now over here we have if, so if price, so look at this, if price depends on demand, that is, we have price is equal to 30 minus X. So now let's substitute this in the formula. So revenue is equal to price. So what is the price over here? So 30 minus X. So 30 minus X, then X. This is the X will be the quantity. Okay, for you guys to understand, let me remove the brackets. So times what? X. So let me do it like this. But in mathematically, you can also do it like this. Into brackets 30 minus X, then you bring X over here like this. Now we have this. So we multiply. Now X is multiplying this. So our answer, let's come here. So X times 30, you are going to get, so revenue is equal to X times 30. You are going to get 30X. Then minus X times, okay, let's omit the minus. So positive or negative times positive is what? Negative. So we are going to get this X. Now X times X, you are going to get what? Squared, X squared. So X squared. So this is going to be your final answer. So this is going to be your final. So as demand increases, revenue also what? Increases. So as demand increases, revenue increases. But after some point, price drops too much and revenue starts to fall. Please do you get it? So this is a real economic behavior. So those of you who did economics way back in SHS, I think this will be simple for you. Now let's look at operations with polynomials. Now the operations over here, we'll be looking at the addition, looking at subtraction, so subtraction, then also multiplication. So these are the operations we'll be looking at today in polynomials. So we'll be looking at addition, right? So let's look at, or let's solve an example on the addition, the operation, the addition sign, or the addition operation polynomials. So let's look at that. So we have, so this is, let me divide it. So this addition, right? Addition example over here. So we have 7x squared plus 3x. So plus 3x plus 3x squared plus, minus 2x. So this is the addition example, we have here. So we have to solve for this. Right. We have to solve for this. So how do we do this? How do we solve for this? So let me clean the board so that we solve for this. Now, let's look at the first example we have here. This is addition operation with polynomial. So we have this. How do we solve for this? So let's write 7x squared plus 3x to bracket plus 3x squared minus 2x. This is simple. So right now, let's look at something. So first of all, you have to figure out or check whether they are like things. So 7 is looks like this, then this also looks like this. So it means they are like things. So we have to group them. So we have 7 over here, 7 squared. You are going to group them plus what? This. So this will come here plus 3. There's no equal to sign, so it doesn't cross. So it maintains with a plus. Then the plus sign over here, that is this. We have plus 3, so plus into bracket. Now we put this one into brackets, then we maintain this one 2. Now we've grouped this, we can add. So we have 10. 7 plus 3 is 10, so still x squared. Now we have this, so let's bring our plus sign here. Now subtracting this, you are going to get x. So this is going to be your final answer. So first of all, you check whether they are like terms before you solve any of this. So you group them, then you solve them. Now another example, let's look at, this is example 2, still on addition. So we have 8x squared plus, or let's do it, okay, plus 4x, right? Okay, let's do this y, plus 4y, plus 4y to bracket plus 2x squared plus or minus, so let's do it, minus 2y. So now we group like terms because we have like terms here. So 8x squared, 8x squared plus 2x squared plus bracket 4y minus 2y. So we add this, you are going to get 10x squared, then plus what? 2y. So this is going to be our final answer. So have you seen another example too? So this is simple. Now let's move to the subtraction operation with polynomials. So over here we have our first example on subtraction with, or the subtraction operation with polynomials. So over here we have 4x. So we solve for this, we write 4x, so into bracket 4x squared plus 5x minus 1 minus x squared plus 3x. Remember, whenever you see a negative sign in front of a bracket, it means there is 1. Or when you see in front of every bracket there is 1 invisible. So 1 times this, you are going to get 4x plus 4x squared plus 5x minus what? This, you are going to get minus 1. Now this negative, we have negative 1. So negative 1 times x squared, you are going to get minus what? X what? Squared. Now negative 1 times plus this, you are going to get minus. It's going to change. Note that negative times positive, you get what? Negative. Always put this in your mind. So you're going to get this. Now, do we have any like terms? Yes. So 4x matches this. So 4x minus x squared. Then 5x also matches to this. So fast plus 5x minus 3. Then we have minus 1. So we subtract this. You are going to get 3x squared plus, we subtract this, you are going to get 2x minus 1. So this is going to be our final answer with this. So this, at the end, we even got what? A quadratic equation. Please, do we get it? We got a quadratic equation. Now, let's move to the multiplication operation with polynomials. Now, let's look at the multiplication operation with polynomials. So, this is the example we have over here. So, x into bracket 6x plus 1. We all know this is a simple equation. You multiply through, right? X is going to multiply, x multiplying what? So, multiplying through like this. So x times 6x, you are going to get, we have double x over here, so you are going to get 6x squared. Then this times this, you are going to get x. We didn't write 1x because in front of this, there is 1. So that's the same thing. So your final answer is 1. So we are done with the operation with polynomials. We did the addition, the subtraction, and also lastly, the multiplication. So now let's move to a business case study examples. We are done, but I want us to look at some business case studies examples, or some case studies that are likely to appear in our exams, maybe similar or the same thing, right? So let's look at some 1 or 2 examples, then we end the class for today. So now let's look at the first business case study, where we have a company model cost using C is equal to 2x squared plus 33x plus 100, where x is the number of units produced. So if we are to interpret this, now we have C is equal to 2x squared plus 33x plus what? 100. Now, if the question says interpret this, over here, the C is the cost, right? The C is the company model cost. So it's equal to, we have 2x. So the 2x squared over here becomes the increasing production cost effect. So the increasing production cost effect. Now the 33x over here becomes, so our 33x over here becomes the variable cost. So the variable cost, because there's a variable here, so the 33 becomes the variable cost, then the 100 becomes what? The fixed cost. So always when you are being asked to interpret something like this, there is an exponent. So the exponent, or the degree, note that we said the degree is the highest power of x. So increasing production cost effect. So that's the highest power of x. So over here, when you're interpreting the increasing production cost effect. Now over here, when we're talking about monomials, we said variables. Now the variable, we made mention ax what? N. So the a was the coefficient. So the coefficient, and the x was the variable, right? So over here, it becomes the variable cost. Now the 100 becomes the fixed cost. Please, do you get it? Yes. Now let's look at another section A practical test or practical exercise. So this is a practical exercise, section A for business maths. So the question 1 says, state whether this is a monomial or not. So we have 3x squared, 3x cubed, that is 3. Sorry, 4x cubed. Then we have 3 over y. Then we have 8xy. So we have to state whether this is a monomial or not. So is this a monomial? Yes, this is a monomial. So this, we say yes, it is a monomial. Now, if I'm a lecturer and you state yes, it is a monomial, and I'm supposed to give you 4 marks, I'm going to give you 2 out of the 4. Why? Why am I giving you 2? Yes, it is a monomial. Why is this a monomial? So there, you shouldn't end there. You should continue. This is because, so this is because it has a whole number exponent. Please, are we learning something? It's a whole number exponent. There, I can give you all the formats. Now, looking at this, 3x, 3 over y. Is this a monomial? No, it is not. Why? No, it is not a monomial. Why? This is because, write nicely. This is because, so this is because it has a variable denominator like this. You are done. What of this? See, we have 8s. Yes, this is, so yes, it is a monomial. This is because, so this is because it has a product of variables. So you shouldn't forget how to identify a product of variables. You should not forget how to identify whether this is a monomial or not. So you see, let's say 4, 4, 4, in all you are getting 16 marks. Shouldn't waste time on this. You get all your 16 marks, you are good to go. You move to the next question and solve. Please, do we get it? Now let's look at another practical exercise. Right now, let's look at this one. Identify the degree of this 5x squared plus 3x, then b x raised to the power 3 minus 4. So when we talked about degrees, we had so this was the table I drew. So we have from degree 1 to 3. Then the names, we had linear, and we had quadratic, we had also cubic, like this. Now, an example of this, the linear, an example was x plus 1, right? Or even 3x plus 1. And the quadratic was 3x squared plus what? 11x, like this, plus 1. Then the cubic was 3x cubed, 3x cubed plus, let's say, 2, like this. Now, so the question says, so we are going to use this. This will be our guide for us to answer the question over here. So identify the degree. So we have, now note that in degree we said the highest power of x. The degree is the highest power of x. So now this is exponent what? 1, but we don't write. So whenever you see an exponent 1, it means it is a linear degree or degree 1, but we don't write. Whenever you see the exponent to be 2, then it is a quadratic degree. Whenever you see the exponent to be 3, then it means it is a cubic degree. So over here, the first one, we had what? 2 exponents. The exponent to be 2. So this is going to be what? A quadratic. So a quadratic degree. And the second one is going to be, so we write it here. The second one is going to be a cubic degree. So please do get it. So whenever you see this, the first one with an exponent 1, which we don't write, that is linear. With 2, it's what? Quadratic. With 3, it is what? Cubic. Put this in your head. Now let's look at the next one. Now let's look at this question. This is a section B question on business application. So a worker earns 12 Ghana cedi per item produced. Write the monomial earnings, the monomial of earning, that is A. Then B, find the earnings for 40 items. So solution over here. So the number of items produced will be X, right? So number of items. So number of items produced is equal to X. Then the worker earns. So the worker earns 12 Ghana cedi per item, right? So they said we should write a monomial of earning. So how do we write a monomial of earning? So the earning will be what? E is equal to, so E is equal to, then what? 12. That's the worker earns 12 Ghana cedi per item. So 12 Ghana cedi. Now we don't know the item. So the item is what? X. Now we've written the monomial of earning. Now B. So this is for A. Now let's solve B for here. So B here. Find the earnings for 40 items. So at first we didn't know the item produced, right? So we said it is what? X. So now let's solve for B. So they said find earnings for 40 items. So E is equal to 12x. At first you didn't know. So now they said 40 items. So you put the x, you substitute 40 for x. So you're going to multiply, you get what? 480 Ghana cedi. So the earning for 40 items is 480 Ghana cedi. So we are done solving for this question. This is a simple question for some 5 marks or 4 marks. Now let's look at a question on revenue. So we have revenue is given by, so R is equal to this 30x minus 40 minus x, sorry. Find revenue when x is 5. So solution, I hope you remember the formula for finding revenue. So revenue, the formula for finding this. So over here we have, sorry, so we are going to substitute because we are finding for the revenue. So R is equal to what? 30x minus x. Then also we have x is equal to what? 5. So we substitute this into the equation. So this is simple. We have our R, the revenue, 30. So the x, they said when revenue, find revenue when x is 5. So the x will be 5 minus into what? So another 5. So you multiply 30 by 5. So you are going to multiply 30 by 5. You get 150. So 150 minus 5. So minus 5, you are going to get 145. So therefore, your revenue is equal to 145. So that is going to be your revenue. That is going to be your revenue. Please, do we get this? So we'll be ending here. On my next video, we'll be solving questions on polynomial operations and also profit model and so on. Thank you all for your time. If you are new to the channel, kindly subscribe to the channel. And also, I gave you some assignments. Please make sure you leave your answers in the comment section. Anything that bothers you too, you can leave it in the comment section for us to look at it. Thank you once again for your time. See you next time.